Hey guys, good morning. How are you? I hope you are well and fine also. Today I will discuss about a NEET and JEE Mains exam. How they are making question for us. Just for a tricky question, I will discuss today about that. There is a question we have. Acceleration is just multiple of time. Second multiple of time meter second inverse 2. Okay, and at t equal to 0, initial velocity is 0 meter per second inverse. And after that, we have to find its final velocity. Final velocity t equal to t will be dash meter second inverse 2. Of course, you will apply the formula v equal to a u plus at. Of course, you will apply. But try to look over here. Here acceleration is not constant over here. Acceleration doesn't uniform over here, so we can't apply that formula. Generally, we are applying like that formula. That is final velocity will be initial velocity and at. If acceleration is positive, then we will put plus. If acceleration is negative, then we are just putting negative sign. Yes, so using that formula, we can find that its initial velocity is 0 meter second inverse. So that is 0 and acceleration is 2t and time is t. We have to find at time equal to t, its final velocity. We have to find over here. So it will be 0 and that is 2t multiplied by t, that is 2t square. Yes or no? So final velocity will be 2t square meter second inverse. Of course, final velocity will be 2t square meter per second. But that's wrong. That's wrong. That's very wrong. You should think about it. If you will try to watch over there, you will see that their acceleration is not constant. It's changing about given time frame. It is not constant, and this formula is just applicable for uniform acceleration. Uniform acceleration. This formula is applicable for uniform acceleration, so we can't apply that formula to find final velocity over here. So what can you do over here? What can you do? Just think about it. Just think about it. What can you do? We are trying to find the final velocity here. First of all, we will consider that this is A and this is T. We will make a graph of Vt. Velocity and time graph will be, that is graph of acceleration. If time is 0 second, then velocity is just 0. It means there is no any acceleration over here. Time is 0 second. If we will put time is 1 second, then our velocity will be 2 meter per second inverse 2. It means that speed is descending with a rate of plus 2 meter per second. If time is 2 seconds, then our acceleration will be 4 meter plus 4 meter per second inverse 2. If time is 3 seconds, then our acceleration will be 10 to the 6 meter per second inverse 2. If time is 4 seconds, then our acceleration will be 8 meter per second inverse 2. So here acceleration is changing in given time frame. So we can't apply this formula because this formula is applicable for uniform acceleration of the particle. If we will look of that graph, then we can easily find the graph because we have plotted the point. So we can make a Vt graph over here, and at time equal to t, the position of particle is at rest. position of particle is at rest. And at time, this is 1, this is 2 seconds, this is 3, this is 4, and this is 5 now. This is 1, this is 2, this is 3, and this is 4, and this is 5. At time equal to t, that is initial position of the particle is at rest. At time equal to 1 second, the acceleration is just like over here. At time equal to 2 seconds, the acceleration is over here. Position of that particle is over here. At 4 meter, at time equal to 3 seconds, our position of this particle is at 6, like that, and so on, So if we will join all the points as we have plotted already, then this will be a straight line, and from this point to this point will be a straight line, and this point to this point will be also a straight line. But all the points are not collinear points. It means our acceleration is not constant, not uniform over here, so we can't apply this formula. And we have to find that t equal to 0 to t equal to t. What will be final velocity over here? And at t equal to t, this is bounded signal. This is bounded signal, bounded function. So to find out the bounded function, we have to find its area. So to find that area, this is velocity, and this is a graph of A. So our velocity will be, we will find area over here because of this signal. This function is just bounded. This function is bounded, so this will be A and dt. And we have to find its final velocity from 0 to t second. This will be meter per second inverse. So this is 0 and this is t, and this acceleration is 2t and dt. Here 2 is constant, so we will put from outside. Then this will be 0 to t, and this will be t dt. If we will try to find this simplification, then this will be t square upon t upon 2 from 0 to t. And these 2 and 2 will be cancelled. This is t squared from 0 to t, that is t squared minus 0 squared, that is upper limit upon minus lower limit, that is t squared. So this final velocity will be at time equal to t, final velocity will be t squared, meter per second inverse. It means velocity is the centric position of the particle is changing according to their square for short period of time. It's applicable for short period of time in classical physics also. But generally in quantum physics it happens generally. So at time equal to 0 second, the final velocity will be 0 meter per second inverse. That is velocity position of that particle is at rest, and if time is 1 second, then final velocity will be 1 meter per second inverse. If time is 2 seconds, then our final velocity will be 4 meter per second inverse. If time is 3 seconds, then our final velocity will be 9 meter second inverse. If time is 4 seconds, then our final velocity is 4 for the 60 meter second inverse. 60 meter per second. At time t equal to 4 seconds, our position of that particle is 16 meter. It covers 60 meter distance at time equal to 4 seconds. So that here our velocity is changing. For this is applicable to short period of time in classical physics also, but in quantum physics that is not. Generally, in quantum physics, there is an uncertainty of everything. We are unable just to find that position of that particle, that velocity, that particle. If it is changing, all the known variable is known. After that, it is not easy to find that position and velocity. of that part. So we can't apply this formula now. Generally, we are applying this formula. We remember that formula from coaching in so many institutes. You did it in 12th also. And if you are preparing for professional degree for college like JEE and Neet, then you should avoid like that. You should think about what's happening over there. This is not constant over there, so you can't apply this formula. Yes, sir? So we have to just integrate it from 0 to 10 to 20 seconds. This is bounded scenario, bounded function. So we have to integrate it to find its area, and we can easily find out that final velocity.